Hi, Martin Burrows here. Hi, David. I'm happy to see you. I'm sorry I came into this meeting a little bit tad late. It's been well, it's important for us to keep the time schedule, of course, and it's sometimes a bit of an obstacle to do so. For this session, we are going to talk about digitalization for sustainability, and I'm very happy to have David here, the BIM Digitalization and Sustainability Coordinator of Sweco. I know that you just came back from Sarek, which is probably where you got all the frost in your hair there,
yes,
or beard, David.
Frost in my hand, chapping in my face, burned by the sun, but happy to be back and happy to present here. Thank you very much, Martin.
You're very welcome. It's all yours.
All right, David Jirout. I am an IT guy who likes to work with sustainability. I develop services at Sweco that help us to this very purpose. And today I'd like to present the tip of the iceberg that we have at Sweco when it comes to delivering low carbon solutions and accelerating circular economy. We have some development regarding communicating biological diversity and other options for improving the sustainability of our AEC projects. But today it's going to be about circular economy, carbon and cost. So without any further ado, let me start my presentation. Let's take a look at the tree I've got here. It has few fruits that we would like to harvest. One of the fruits is that we want to make sure that our grandchildren will have the security of resources for their development. Perhaps in 2050, they'll have to refurbish a hospital, improve housing, etc. And that's something we want to make sure happens. At the moment, the preconditions for that are very low, and I'll talk about it later. The second fruit we would like to harness is low carbon and cheap construction and achieve win-win solutions. Third fruit we would like to harvest would be to focus and prioritize right in the design process so that we would know where are the biggest problems from the sustainability point of view, such as carbon driving materials or carbon driving solutions and systems. And we want to help the design team to focus right to tackle these problems. And these are the fruits that are on my sustainability tree, but they will not grow on their own. There's quite a journey we have to take to get there. So let's take a look at the roots of these fruits, the good and bad. Today, we are using BIM models to communicate the concept behind the design, and in some cases, even produced by the BIM model, which is very positive. BIM models are the base for facility management, calculation, and even carbon accounting. But very often during the design process, somewhere in the process, we stop to develop the BIM model, we export the information and take the information to another software to do other work, such as doing carbon accounting, calculation, facility management, etc. But the BIM models are nearly there. They could do and deliver all of these services if we would focus on them a bit more. I would like to introduce something that I call the organic potato bias. If you go to a shop and you want to buy grocery and you look at potatoes and you see that the organic potatoes are more expensive than the non-organic, and you see that the carrots that are organic are more expensive than the non-organic, you'll think that the same applies in other parts of industry. We live in a society with a bias that believes that environmentally friendly construction must necessarily be more expensive. And we have developed a service that I will show you in a second that proves there are cases that is exactly not so. There are win-win scenarios and we must harvest them. So in the Nordic smörgåsbord style, you know, the Swedish table style, you can have it all. You don't have to compromise between either cost-effective or low carbon. You can have both cost-effective and low carbon. I'll show you how to get there just in a second. There's a problem we have in the AEC industry and in other industries, and that is nobody understands carbon numbers. We are communicating climate calculations in kilograms or tons of CO2 equivalent. But let's be honest with ourselves, how many actually understand those numbers? How many of us actually know what is the carbon footprint of our lifestyle per year? Carbon numbers is something we do not work with on everyday life. And somehow we expect that when the environmental consultants or the LCA analysts come to the design team and say how much carbon they've got connected to their design, they'll know exactly what to do. Well, they don't. I've had many experiences with that, and we have to do something else. So I would like to ask, a really serious question. How would Winnie the Pooh communicate carbon footprint? Winnie doesn't know what is carbon footprint, neither do much of our engineers. Until we learn to work with carbon numbers in everyday life, such as with costs, we will not know how to react to those numbers. And we have to figure out different communication strategies to communicate sustainability in projects. So how do we get to the low carbon and cheap? How do we communicate better? And how do we make sure that future generations will have resources for their own development in the future? Let's take a look at what we have at Sweco. First, the case of communication. We have developed a service that we call carbon cost visualization. It's about taking carbon numbers and translating them into a color palette. Red is bad, blue is good. We are using alarming colors to communicate what and where in the model we have carbon driving numbers. We are developing the BIM model in such a way that every user can recalculate, can visualize, can get insights on where do we have carbon in our design. Here we see numbers. Yes, numbers are important, but sometimes they just need to be a base, not the means to communicate. Now, here we've got an example where the stairs stand for the most carbon driving. The same for roof. And thus the design team can sit together and discuss, what do we do about roof? What do we do about stairs? Do we have even the right materials in the BIM models? Or why does it spike out? We have to integrate environmental analysts and LCA guys with the BIM team and with the design team. And BIM models are a great way to do that. So by carbon cost optimization, we are visualizing, integrating, and democratizing who can do climate calculations, consume them, and who can get insights. You won't have to wait for calculations to be ready to take the right decisions, because the emission factors and other sustainability factors live inside the model. Let's take a look at another example. Carbon cost optimization. What do we do about the organic potato bias? I'm really proud to announce that my colleagues at Sweco Structures have done some outstanding work on utilizing evolutionary algorithms in Grasshopper, where we optimize the geometry and the material choice behind the foundation slabs that we have in this very example. The AI will get to choose to manipulate geometry, X, Y, and Z of the foundation slabs in this example. And it will even play with the materials, different types of concrete in this case, and their respective bearing properties, carbon emission factors, and costs. Now the machine learns over time, figures out, okay, if I do this, then carbon goes up. If I do this, cost goes up. And it has the objective to optimize both aspects, both carbon and cost. Now, every cube in this visualization represents a solution that has passed the bearing criteria. So that means that the foundations will do their job to bear the building and bear the loads. However, you can see that on this axis, we've got global warming potential in kilograms of CO2. Here we've got costs, and each solution performs a bit differently. Now, this is a type of a problem where optimization in carbon will lead to optimization in cost. Now, don't mix this up. Optimization in cost does not necessarily need to optimization in carbon. However, in this case, optimization in carbon will lead to optimization of cost. And there is the cheapest and the low carbon solution right at the axis that we can pick up and sync with our models, such as in Tekla or Revit. Right. The legacy database. We have developed a concept and property sets for Revit that can communicate circular economic aspects directly in the BIM models in Breakout. Today, in order to assure that future generations will have resources for their development, we must make sure that we have BIM at the edge and pass on the information about materials, ISO certificates, product names, product codes, manufacturers, energy used, and much more. This information must be passed on to the future generations. Today, developers and facility managers are sitting on information about their buildings on their own. And this is wrong. This must change. I'm not saying that all information about the building must be shared with the society, but let's take a look at this. I will come back to this slide later on. This is a map of minerals and their presence in Sweden. In the past, we have developed from non-renewable materials, such as steel, such as concrete, etc., fossil fuels. Now, these bubbles represent the deposits of minerals in Sweden. And over time, these bubbles get smaller and smaller and smaller as we build with non-renewable materials. Now, what happens to these minerals? There's two stories. One of the story is a story we do not like to see. That's the story where materials become just trash over time. We are living in a linear economy. We buy, throw away, dispose. This is what happens to these mineral deposits that we are mining. Sometimes they get recycled, sometimes they end up on the landfill, but there is an end to these resources. There's a second scenario where these resources get actually locked up in something useful that's being maintained over time, such as infrastructure in terms of roads and railroads, electricity, power lines, etc., or the cities. Here I've got a map of Uppsala, the city I live in, from 1770. Now, those bubbles on those maps with resources, they were pretty large at this time. But as the city grows over time, the bubbles get smaller and smaller. And this is a story of many cities. They've just expanded. And it is quite possible that during our lifetimes, resources will not be present enough for the future generations to develop themselves with, not with the old model, with linear economy. So what we have to do today is that we would have to connect the as-built models that we deliver to the customers and connect it with a decentralized database such as blockchain, so that everybody would know where we have strategic resources. Now, this is not a question about using BIM for something more, but it's simply a question of meeting the needs and surviving. BIM will become the necessary preconditions for our future generations to know where they can disassemble buildings to get materials they need to meet their needs. Now, if we use structural steel and we do not communicate in the BIM models what is the bearing properties in terms of ISO standards and etc., they will not be able to recycle it as the bearing steel. And this is exactly what we are developing. We're developing a service where we can take all this information that is important for 2050 or 2100 to make sure that the BIM models will become the base for recycling the environment, the built environment, to meet the future needs, because we cannot count on virgin materials to be present. And we shouldn't, because every time a new deposit is discovered, biodiversity and water quality gets to hit. So what has to happen is two things. The government must take responsibility to set up national blockchain databases for the strategic minerals for the built environment. We must know where we have concrete distributed. When we have a map, we must be able to zoom in. BIM and GIS integration is coming, it's getting better and better. But we must know where we have steel, where we've got plastics, where we've got the strategic minerals we are so desperate of for our development. And facility managers can no longer sit privately on their information regarding that. Not saying that we should share information on doors and security, but the strategic minerals should be in blockchain. And then we would have taken BIM a bit more seriously. So this is where I would like to open up space for questions. Please do get in touch regarding BIM and blockchain and circular economy. It's me and my colleague Ella Sieg. Carbon cost optimization with Grasshopper, like you've seen, Samir El Murabit and Simon Larsson. Carbon cost visualization, Winnie the Pooh, how would he communicate carbon? That's me again and my colleague Arturo Leon. And carbon cost management in infrastructure, Tabitha Grandal, and in buildings, Anna Joelsson. We're happy to help you achieve more sustainable AEC development. So with this, I would like to sum up, and let's open up the stage for questions. Thank you, Martin, for inviting me.
Here we go. Now press the right buttons. Thank you very much, David. Let's see here in the Q&A. We don't have any questions that people have written in here. What I would like to, well, I had some more questions about the last things that you spoke about, the, saying circular economy, but how much of the blockchain stuff regards, let's say, new sources of, mining, and how much do you mean that would be towards the recycling parts?
So if we 2020 produce BIM models that we pass on to facility management that will contain all of the information necessary for reuse, recycling, upcycling, and downcycling, we will not have to mine as much. We will not have to exploit as much. Now, as resources get scarcer and scarcer, they become also more expensive. We are a society that passes on its debts on future generations. And we are increasing the environmental debt, the carbon debt, and we are depleting non-renewable resources. BIM is a base and must serve as the base for circular economy for the built environment, so that materials will be present for AEC and also for industries and also for other stuff.
Excellent. Then we have a question there. Are there any incentives for the construction companies today to choose material that are more environmentally friendly and recyclable, but perhaps more expensive?
Absolutely. There are many incentives, such as the demand of the customer, the national carbon targets, the ever increasing prestige and competition in developing buildings more sustainably. And if we take a look at some environmental certification or certification of the buildings such as BREEAM, LEED, Milia Byggnatt in Sweden, they are pressing the market towards using the more environmentally friendlier solutions. So yes, there is an incentive.
And Maria has a question here. Do you know if the efforts that you are doing is, well, if they are linked then to the work with the Swedish national standards, such as nationella riktlinjer, K-class, and so on, to be able to talk the same language also for sustainability information on objects?
Co-class, BSAB codes that we use in Sweden are not going to meet the needs of communicating well enough structured information that we need for LCA and that we need for circular economy. Let me give you an example. You can have a door. That door can be made out of glass and wood, like I have behind me. It can be made with steel. It can be made with other materials, composites, homogeneous materials. Now in BSAB, the door would have the same code. In Co-class, there might be perhaps more nuanced stuff. But let's say we have two steel doors, and one is made in Poland, one is made in Norway with renewable energy. The EPDs, environmental product declarations, and emission factors connected to the doors are different. So we have to integrate EPDs and emission factors into BIM. At Sweco, we have done the support for that for Revit. With Symetri, we want to create a plugin for BIMI that would offer you this very support and integration of sustainability aspects into BIMI. But Co-class will not do the job and communicating environmental needs properly. It's not nuanced enough.
And we have another question here from Bogdan. It ties on to this. How to get better information from materials that are imported into the country or in the country? So I guess that ties down to a little bit what you just said with if there are international standards and how you can keep track of stuff when it goes over borders.
Complicated question. So EPDs are the best source of information at the moment about environmental aspects. I see a lot of potential in track and trace solutions provided by Oracle, Microsoft, including their blockchain infrastructure for validating who has produced what in what way. We have examples today, such as Volvo, who are sourcing their cadmium for batteries from recycled batteries only in order to prevent child labor from sourcing new cadmium, etc. So track and trace is definitely the way to validate that stuff is sourced properly, and EPDs gather the information on environmental impact.
Yeah, track and trace. There are people commenting, such as Mats here, saying that he sees traceability as one of the keywords, or actually it's a question, but I guess you would agree on that, David.
Yes.
Yeah, Nicholas John here, he has another question a little bit regarding not only the track and trace, but also the timeline, because obviously in order for us to be able to track the concrete that's going to be in an infrastructure for a long time, we need to have some kind of future compatibility. Can you say something about that, David?
We do not know what the future needs will be. The best we can do is that we pass on as much information as possible about how materials were sourced, produced, what are they made of, if they're homogeneous, if they're composites, what are the standards. And we will see what the future does with that information. Today we are inheriting drawings in paper when we are rebuilding buildings. The geometries do not fit. We don't know nothing about materials. This mustn't happen again.
Excellent. And there are some other people in the chat giving you some thumbs up, David. I would like to do so as well. Inspiring presentation and inspiring to see you walk at the same time as you present. That's pretty much the first time I've seen that, and it's inspiration for me. We have one last question though. It's how about transport on building site? Of course, transportation of materials and also transportation on the building site is contributes to a negative impact on sustainability and environment. Is there something you can say about that as a few last words here to wrap up?
Transports are communicated within EPDs, not to the site itself. Here, it's very important that we demand the entrepreneurs to electrify or go for hydrogen-powered heavy vehicles and logistics, so that we achieve carbon neutrality in transport. It looks really well. There are electric trucks coming, hydrogen trucks coming, so I think we'll be able to achieve climate neutrality within transport, at least when it comes to fuel use. On the ships, there is a lot of interesting initiatives with gas, such as methane, that would be able to power ships from Shanghai to Rotterdam, for example, in a carbon neutral way. So there are definitely solutions for carbon neutrality within transport. And for example, Maersk, the Danish company in logistics, have decided to already launch their carbon neutral vessel in 2023, I think. That's going fast. We have to demand better. We have to be more daring, because tech is developing faster and possibilities are opening up faster. I think that it's our demands that are always looking how it was in the 60s or 90s or 10s, you know? We have to catch up with what's out there.
All right, thank you very much. What happens now is that the next we have a break for half an hour, and during the break, please check out the networking part and also the expo booths. I'm going to see the networking part, how that works of the Hop-In platform here. So maybe I'll meet some of you there. And the next session starts at 11 o'clock, so a little bit more than half an hour. Thank you very much, everybody. Thanks for attending, and thank you very much, David.
Thanks for inviting me. Take care, guys. I'll be on the networking platform until 15 o'clock today. So feel free to get in touch. Add me on LinkedIn.
Yep. Right.
Bye-bye.